Exercise 21.3, question 5, part 3. So here we've got a football being kicked 30 metres from a goal at a velocity of 18 metres per second and an angle of 55 degrees. So in part 1 you're asked to find the horizontal and vertical components. So we know that as a vector, the initial velocity is 18 cos 55, 18 sine 55. And we're asked in part 3, well, we know that there is a goal 30 metres from where it's kicked. And we know the height of that goal is 2.5 metres high. So you've got a height of 2.5 metres high. So your question really is, when the horizontal distance is 30, is the vertical height bigger than 2.5 or less than 2.5? And actually, does it even reach the goal? So I suggest what we do is we try and work out what is the height when the horizontal displacement is 30. So let's call this height y. And let's model this problem using our vectors. So we've got u, and we want to know what is r at this point here. So the vector r, at this point here, we know the horizontal displacement is 30, and the vertical displacement is y, and this is the y that we want to find. Well, we know what a is. We know that a is 0 and minus g, because this is acting only under the influence of gravity. So again, we're going to use the Suvad equation. R equals ut plus a half a t squared. So putting this information into the equation, we have 30 and y equals 18 cos 55, 18 sine 55 t minus a half 0 minus g t squared. Well, taking the horizontal components, you get 30 equals 18 cos 55 times t. So t is 30 divided by 18 cos 55. Well, this should be your answer to part 2. I'm not going to work out what it is numerically, because I know that I just need to substitute this into the vertical components to find out its vertical height after 30 metres. So let's put this into our vertical component. Our vertical component is y equals 18 sine 55t. Minus an error there, that should say plus a half of minus g t squared. So y equals 18 sine 55 t minus g over 2 t squared. And substituting in this value for t, we get y equals 18 sine 55 times 30 over 18 cos 55. Notice that is just 30 tan 55 minus g over 2 lots of 30 over 18 cos 55 squared. If you put that into your calculator and calculate it, that gives you an answer of 1.47 meters. So let's go and think about what that's actually saying. So that's saying, if we go back to our picture of the projectile, this projectile, we know that when the horizontal displacement is 30, this has a height of 1.47 meters. So that tells us that it doesn't go over the crossbar, but actually it doesn't hit the ground before the line either. So this definitely goes straight into the goal.